Ever wondered how to manage application configurations in Kubernetes or how to securely store sensitive data? You're in the right place. Kubernetes, fondly known as K8s, is a game changer in managing containerized applications. It's like a maestro, orchestrating a symphony of containers, ensuring they perform in harmony. But how does it manage configurations and sensitive data? That's where ConfigMap and Secret come into play. ConfigMap, as the name suggests, maps configurations to your applications. It's like a dictionary, storing non-sensitive configuration details in key value pairs. On the other hand, Secret is the secure vault of Kubernetes. It tucks away sensitive information such as passwords, SSH keys, and tokens safely from prying eyes. These two components are the unsung heroes in the K8s ecosystem, playing a pivotal role in ensuring smooth and secure operations. Stay tuned as we dive deeper into ConfigMap and Secret in Kubernetes. So, what exactly is a config map in Kubernetes? Think of ConfigMap as a way to inject configuration data into your applications. It's a Kubernetes object that lets you decouple configuration specifics from your containerized application images. This means you can maintain your applications portable and easy to manage. ConfigMap is designed to store non-confidential, unencrypted data. It allows you to centralize and decouple configuration details from your application code. This makes your applications easier to maintain and more flexible to different environments. Picture this. You have an application that requires certain configuration data to function correctly. This could be anything from database connection strings to server names or even debug flags. Instead of hard-coding this data into your application, you can use ConfigMap to dynamically inject these values. Here's how it works. You create a ConfigMap object in Kubernetes. This object can hold key value pairs of configuration data. Once the config map is created, you can reference it from your application pods. These pods then access the configuration data contained in the config map at runtime. Creating a config map is straightforward. You can create one using the Kubernetes command line interface, kubectl, or by defining a config map in a YML file. The YML file approach is often preferred because it allows you to manage your config maps as code and keep track of changes using version control systems. Once the config map is created, your applications can use it in several ways. They can read the config map data as environment variables, command line arguments, or as files in a volume. This flexibility allows you to use config maps in a way that best suits your application architecture. Remember though, config map is not a secure store for sensitive data. For that, Kubernetes provides another object called Secret, which we will discuss in the next scene. That's ConfigMap for you, a versatile tool for managing non-confidential data in Kubernetes. Now let's turn our attention to Kubernetes Secret. Imagine this, you're a spy and you've been assigned a mission. The mission details are too sensitive to be communicated openly. So your headquarters send you an encoded message. Only you know the secret code to decipher the message. Kubernetes Secret works in a similar fashion. Kubernetes Secret is a mechanism designed to store and manage sensitive information. This includes passwords, OAuth tokens, SSH keys, or even your secret mission details. It ensures that this sensitive data isn't exposed in your application code or accidentally revealed to unauthorized individuals. The concept is straightforward. You take your sensitive data, encode it, and then store it as a secret in Kubernetes. It's like locking your precious jewels in a safe. This secret is then accessible to your application, which can decode and use the data when necessary. But how do you create a secret? Well, it's as simple as creating a YAML or JSON file that contains your sensitive data. You then use the kubectl create secret command to create a secret in Kubernetes from that file. The data within the secret is automatically encoded and securely stored. However, keep in mind while creating secrets you need to be a bit cautious. The data is only base 64 encoded, not encrypted. This means if someone gains access to the secret, they can easily decode the data. So always ensure to restrict access to secrets and use them judiciously. Now, how does an application use a secret? An application can access a secret in Kubernetes in two ways, through environment variables or by mounting the secret as a file in a pod. The application can then use this data to authenticate itself or perform other sensitive operations. In essence, Kubernetes Secret serves as a secure vault, safeguarding your sensitive information. It decouples sensitive data from the application code, enhancing security and easing the process of updating the data should the need arise. And that's a wrap on Kubernetes Secret, an essential tool for managing sensitive data securely. You might be thinking, what's the difference between ConfigMap and Secret? Well, let's get into it. ConfigMap and Secret both serve as objects used in Kubernetes to separate configuration details from the container image. The crucial difference lies in the data they hold. ConfigMap usually stores non-sensitive, plain configuration data in key value pairs, whereas Secret is designed for more sensitive data like passwords, tokens, or keys. Now, when should you use each? Use ConfigMap when you need to store non-sensitive configuration details, like settings or options. On the other hand, Secret should be your go-to for storing sensitive data. Remember, Kubernetes doesn't encrypt secret data by default, so it's advisable to employ additional security measures like enabling encryption at rest for your cluster. In essence, both ConfigMap and Secret are indispensable in Kubernetes. They ensure your applications remain flexible, reusable, and most importantly, secure. Before we wrap up, here are the key points to remember. ConfigMap and Secret are two fundamental components in Kubernetes that help manage application configurations and sensitive data. These tools allow us to decouple configuration details from our containerized application code. ConfigMap makes it easier to maintain configuration parameters such as database connection strings or file paths, which can be dynamically updated without having to rebuild or redeploy your applications. On the other hand, Secret is designed to hold sensitive information like passwords, SSH keys, or tokens. It ensures this data is stored securely and only accessible to authorized entities within your Kubernetes cluster. Comparing the two, while they serve different purposes, they both contribute to a more secure and efficient Kubernetes environment. Mastering these elements will undoubtedly give you a significant edge when handling applications on Kubernetes. Remember, mastering ConfigMap and Secret can greatly enhance your Kubernetes skills. Thank you for joining us today, and we hope to see you in our next video.